So let's go ahead and work through a couple of examples and see how this works. We're going to start off with a trig function. See, this is sine of 2x. This is not just an x. So this right here is a function. It's the function g of x. That didn't look much like an x, did it? Sorry about that. G of x. There we go. So this is actually sine of g of x. So what this is going to be, the derivative of this, d dx, is going to be equal to the derivative of sine of g of x times g prime of x. Well, we know the derivative of sine is cosine, so this will be cosine of 2 of x times the derivative of the inside. So that's 2x prime. Well, 2x prime is just 2, so this equals cosine of 2x times 2, which obviously you'd write as 2 cosine of 2x. Now this next one is simply a simple polynomial raised to the second power. So you could simply expand this thing and then take the derivative of the polynomial, which is one approach, but rather than expanding it, I'm just going to apply the chain rule. So it's a derivative of the outside, which would be 2 times whatever I started with. This is to the 2 minus 1, so it's just the first power, times the derivative of the inside, which is 3x plus 7 prime. Well, the derivative of 3x plus 7 is just 3, so this will end up being 6 times 3x plus 7, and then you may or may not want to distribute that through there. It's kind of your call. Okay, what we've been doing with those, with this last example, is actually this is an application of the general power rule. Now, here's the theorem: if y equals u of x to the n, which what we had here, this would be what we're thinking of as u of x, and of course it's raised to the n. In this case, raised to the second power. Where u is a differentiable function of x and n is a rational number, that's exactly what we have, because this is a differentiable function of x, and 2 is a rational number. It's 2 over 1. Then the derivative dy dx equals n times u of x to the n minus 1 times u prime of x. This is exactly what we just got done doing. This theorem is also commonly referred to as, like I said, the general power rule.